In this last video, I'm going to show how we can use completing the square, that process, to rewrite a trinomial that's in standard form into what we call vertex form, which is something that we really, I would say, truly appreciate. And the reason why is because when we complete the square, it's basically taking a perfect square trinomial and rewriting it as the square of a binomial. When we look at standard form side by side with vertex form, which is this ax minus h quantity squared plus k, you can see that really what we really want to get out of this trinomial is to rewrite it as the square of a binomial, which necessarily would put it into vertex form. So I'm just going to kind of demonstrate the process you go through here to rewrite this into vertex form. But the first thing I want to do is I want to start by amending a little f of x equals here. So what I want to do here is we've gotten some function in standard form. It says write the following equation into vertex form, then identify A, the vertex, B, the axis of symmetry, C, the max or min value of the function, D, the zeros, or what we call the x-intercepts, and then also the domain or range after we sketch it. So right now I certainly could go graph this. It's in standard form. We could find the axis of symmetry by using the fact that it's equal to negative b over 2 times a, but I'll tell you I'd rather have this into what we call vertex form. So completing the square, remember that the first step we always complete is to displace this constant term here. So we would really have f of x minus 10 is equal to now 2x squared plus 12x. And so the thing we want to do here is when we complete the square, we're going to have an a value that is equal to 1. So if we were to split everything in half here, split both sides in half, we're going to need to keep that half value, but I really get this. I get 1/2. I'm going to write it this way. We say 1/2 f of x minus, now 10 divided by 2 is 5. I would get this. And then on the right side, we would have x squared plus 6x, which are half of these values. Now we're really just going to add on half the middle term squared, which in this case, half of our middle term is 3, and 3 times 3 is, well, 9. So I'm going to add 9 to both sides of this equation here. And so the right side folds up into this square binomial, since it's now a perfect square trinomial, where positive 3 is half of our middle term that goes in this binomial value. And here we have half of our y value is equal to negative 5 plus a positive 9, which adds up to be a positive 4. And so the last steps we need to carry out here are these. We're basically going to bring this loose term back over. We get 1/2 of our y value here, in this case, is equal to this x plus 3 squared minus 4, and then to get rid of this half here, we're going to take both sides times its reciprocal, which cancels these out, and we just get f of x. Now the important thing here is we need to take the entire right hand side times 2 over 1. So this means I'm going to take 2 times this quantity and 2 times this quantity. We basically get 2 is our a value. It was our a value to begin with up here, and so it still must remain our a value down here in vertex form, but 2 times this x plus 3 quantity squared, and then 2 times the negative 4 is negative 8. And so identifying the vertex, let's go ahead and confront this here. We have a, h, and k, and our vertex is always at the values h and k respectively. So we say negative 3 and negative 8 is our vertex value. And so looking at this, if I were to graph this, I go left 3 here. Maybe I'm going by ones here. We say 1, 2, we'll call this negative 3. But to go down to negative 8, I'm going to have to go by 2's, it seems. So I'll call this here negative 10. We'll go by 2's on our y-axis. So left 3, down 1, 2, 3, 4 notch marks, and we're going to label this. And so knowing that my a value is a positive 2 here, I know it opens upward. I'm going to label this off underneath it. We say negative 3 comma negative 8. And its axis of symmetry, recall, is that vertical line that must run through the vertex. So we certainly know its equation is an x equals, and has to share the same x value as our vertex. So really we say x equals negative 3 right here. And so sketching the rest of this, we would say, given the fact that it has an a value of 2, I would, as I go right 1, I would go up 2 instead of up 1 like our parent function. So they say up 2 units over 1. That would actually put these two values here. And I would say that this is probably at this point decent enough to get a curve that proceeds through these here. Okay. So here's our function. So I'm asking what's the min or max? Well, by observation, we can have no maximum value here because it always goes upward. But it certainly has a minimum value. We say the minimum value this function ever gets to is negative 8. So we would say negative 8 is the minimum function value. Speaking of minimums, we'll talk about range as well as the domain, but the domain of this is all real x values. The simple fact is this graph goes left to right forever and ever and covers every x value on the x-axis. But in terms of range, I noticed that we only hit y values that are -8 or above on the y-axis here. So we would say y is greater than or equal to -8 for our range values here. But again, essentially what we could do is we could use this completion of the square to rewrite this into vertex form, since what it does is gives us a square of a binomial. So there's only one thing we have left to do in this video that I didn't write down here on this set of things we wanted to find, but I asked to find the x-intercepts or zeros. So I noticed that this has to have two x-intercepts here, and it kind of looks like -1, and I guess this is 2 to the left of -3, -5, but see, this is just a sketch. So if we actually want to find these algebraically, what we'll do is we'll take our y value here, and we'll say let's let y actually equal 0, and then what we'll do is we'll go back and solve for the x values that cause this to happen. So what we'll do is we'll start by getting the squared item by itself. This means we're going to have to add 8 to both sides. So bringing that 8 back over to the left here, we would get this. We would say 8, I'll kind of scroll down a little bit here, 8 on the left hand side is equal to 2 times x plus 3 squared on the right. And then getting this squared thing by itself is going to require us to divide by 2 here. We get x plus 3 squared is equal to 4. So now we'll take the square root of both sides, and we get x plus 3 on the right. On the left we get plus or minus 2, and then I guess scrolling down even further, we'll see how far I can scroll down here. Good ways. So we'll say subtract 3 from both sides. And so in this case, we're going to verify that we'd say for x we get -3 plus 2 and -3 minus 2. This means that we get, well, -3 plus a positive 2 is -1. And we say -3 take away 2 is -5. And so I have indeed confirmed that on our graph here, the zeros of the function, or the x values that when we plug them in we get 0 for a y value, happen to be -5 and -1.